Okay, this video is called Globe Plane equals no. This here, right, I have this globe out here in green and into blue here. This orange serrated line is a 6 miles above the globe altitude, right? This blue serrated line is the actual direction of plane flight. So planes only fly in straight lines. Now they can do acrobatics and stuff like that. Jet fighters not, but that happens within a few miles cubed. That won't be happening over any kind of distance. If a plane is flying any distance at all, it has to fly in a straight line. Okay, because the reason is that planes must fly with an above horizontal pitch of their wings to generate enough positive lift to account for weight. So to have 100% positive lift, you must fly with an above horizontal pitch. The pitch is determined by the airspeed. So a slow airspeed will have a higher degree of pitch, and a fast airspeed will have a lower degree of pitch. But the pitch will always be above horizontal, because even with a cambered wing, which does have the ability to generate a certain amount of positive lift, more than other wings, with a below horizontal pitch. But even with a cambered wing, even a 2 degree below horizontal pitch, you'd be lucky to have 65% positive lift generated from that. So even with a cambered wing, to oppose 100% of the lift to oppose 100% of the weight of the plane, the pilot must fly, even with a cambered wing, with an above horizontal pitch. Okay, planes fly from A to B in straight lines. That's what they do, right? They might change altitude here and there, but they must contact ground control. Commercial aircraft especially must contact ground control to request that they want to change altitude, because there's all kinds of sky highways up there. Different planes flying in different directions at different altitudes. So pilots must request. They can't just randomly do it. From as far as I know, they must, from what I've seen, they must request to drop an altitude, which makes sense, because they could be dropping to an altitude where there's another plane flying straight towards them. So they must request to drop that altitude. So that means they must hold them at the altitude they're at for as much as they can, unless there's weather or whatever. Then they must request to change the altitude if they have to. But if they don't have to change the altitude, then they will be holding that same altitude, which means, and if most of the time they'll be holding a cruising speed, right? And cruising speed will normally have, at cruising speed, they normally have a +3 to +5 degree above horizontal pitch. That's their average for the average cruising speed, right? So consequently, they're going to be flying in a straight line at the same speed. Let's say they're flying at 550 miles, right, per hour. They'll be flying in a straight line with a pitch of about +4 degrees, right, between this point here and this point here, right? This line here, this blue serrated line, is 550.2 miles in length. This arc length here between this point and this point is 550.2 miles as well. Well, 2.6 is slightly bigger, the arc is slightly bigger, right, than the straight line. So both the arc and this blue straight line are the same length. This orange serrated line is also basically the same length as the blue line and the green arc length here, right? So they're all close on 550 miles. So I've already explained why a plane can't fly in any other way from A to B other than straight. It must go on a straight line. But if the Earth was a globe and planes were trying to fly, and pilots were trying to fly planes around a globe, then they'd have to start at this point, which is 6 miles above this is a 6 miles altitude above this globe surface, and end up at this point here, right, 1 hour later, right, if they're flying at 550 miles per hour. And the problem with that is, to do this, right, if they just tried pitching down, right, at this point and trying to fly straight, they go from this point to this point, they're going to smash into the globe surface at 104 miles, right, into their trip, right? Now, this is also means that they won't have lift. They're going to lose lift as soon as start losing lift, regardless of the wing type. As soon as they pitch below horizontal, they're going to start losing lift. So not only are they going to be losing lift, but if they try to do a straight line path, they're going to smash into the globe surface. So that won't work. They can't just have account for a 3.98 degree below horizontal pitch. They wouldn't be able to do that, right? Even in Magic World, they wouldn't be able to do it. That would be Magic World would be where they're flying without any lift, which would be over a globe. That's what they'd have to do. The lift effect wouldn't exist. Let's just say, right, over a globe. So what they'd have to account for is actually 7.97 degrees of pitch. So, right, so 7.97 at 39, right, let's go with that much. So that would mean that over the course of an hour from their starting point, if we divide that by 60 minutes, right, that would mean that the pilot would have to account for 0.13, would have to, from the very first minute, would have to have, after a starting point of horizontal, there'd be never an above horizontal pitch. The pitch, once the plane reached cruising altitude, that'll be it. It would have to, once the plane reaches cruising altitude, it'll be horizontal or straight for one moment, and then for every minute after that, the pilot will have to add, subtract 0.13 of degrees of pitch from that horizontal. So and then the next minute 0.13 degrees of pitch, the next minute 0.13 degrees of pitch. So minute by minute by minute, the pilot is gradually having a more and more and more below horizontal pitch. Now, officially, any below horizontal pitch is a descent, right? Officially, according to Boeing, Lockheed Martin, all of them, it's a descent. So any below horizontal pitch is considered a descent towards the surface of Earth. So how could a pilot be flying and accounting for 0.13 degrees, which is very precise if you're trying to be a pilot, 0.13 degrees of pitch, right, for every minute over the course of an hour? How could a pilot do that, right, and fly then without lift and fly in an arc? Can't. It's impossible, right? It can't be done. Like if we multiply this by 20 minutes, right, then after 20 minutes, they'd be already at 2.65 degree below horizontal pitch. Even with a cambered wing, you'd be lucky to have 45% positive lift with a cambered wing at 20 minutes into that flight. That means there'd be 55% of the weight of the plane being unaccounted for. 55% of the full weight of the plane being unaccounted for. There's absolutely no way they could do it. It would just be dead ends. Impossible. Certain things in life are impossible. And planes flying over a consistently curved surface of a globe is impossible. Which means either air travel exists or the globe exists. It's that simple. Air travel and the lift effect exists or the globe exists. We both know the answer to that. It's a process of elimination. Obviously, air travel and the lift effect exists. That means the globe can't exist. It's that simple. There can't be a globe and airplanes exist. Simple as. So, just to finish, there's absolutely no way for this to work. It can't work. Planes only fly in one way. They only fly in straight lines. They don't fly around globes. That can't work. Can't happen. No matter what way they try to do it, it wouldn't work. Because as soon as they are not flying in a straight line, as soon as they're pitching below this straight line, because they have to pitch above this straight line slightly to generate the lift, they need to fly. So if they're pitching below it, which they'd have to do in this position, like there's no way to not. This is the direction of flight. This is where they'd have to be on a globe, right? Look at that. Like basically, if they were to fly as they actually do fly, and there would be a globe, there'd be a constant change in altitude, right? Constant change in altitude. And to change altitude, they must request permission from ground control. They can't just be changed. They don't just change altitude like at will whenever they want to. They must let ground control know they need to do it because of weather or whatever. Because there's sky highway up there, all kinds of planes up there flying in different directions. And you could be dropping altitude or raising altitude and going in straight into the path of another plane. You can't just do that. You must request permission. So that means they'd have to hold their initial altitude as much as possible, and they'd be probably holding their airspeed. Most of the time, they'll hold a consistent airspeed and a consistent altitude. So a 6 miles above the Earth altitude and 550 miles per hour for a big commercial airliner, right, would be pretty much standard. And to do that, they have to have an above horizontal pitch to be able to fly in the straight line. It's just no way out of it. It's just, as I said, some things in life are impossible, and it'd be impossible for airplanes to fly around the globe. Just completely impossible. Like, I know I've said it before, but I just think it's one of these videos that need to get made every couple of months, because people need to learn. Like, it's just it's not happening. In the story, I'm sorry you don't like it. It's just not happening. It's impossible. So it doesn't matter what. I don't care if they're going from Sydney to Santiago or Santiago to Mars. I don't care, right? What the airlines say, how they do what they do, how they say they do what they do, it means absolutely nothing to me, because all that matters to me is I know how the basics of the plane, how they must fly. I know what lift effect is. I know what lift does, right? I know how they must fly, right? I know about the onboard instrumentation. I know about the navigation systems they have. I know about their gyroscopes, all these things. They can't fly and follow this orange serrated line. They just can't do it. It's not possible. End of story. They can only follow this blue serrated line. So if they're holding an altitude and this is their direction of flight, this blue serrated line, obviously the Earth that's underneath them is not this curved nonsense here, is it? It can't be. It's impossible. It's impossible. Sorry, it's over. Like, there's no way around it. No matter how much you brace against this, it won't change reality. You can brace against reality, but you'll never change it. It is what it is. The sooner you just accept it and move on with your lives, the easier this will be for you. Okay? Thanks for watching.